Okay, we're on the law of Hess. So, for the first question, you're trying to get an overall reaction of 2NOCl yielding N2 plus O2 plus Cl2. So that's your goal. They gave you two different reactions that you have to manipulate. The first reaction that they gave you has got nitrogen monoxide on the product side. So let me just write them off to the side here. Okay, I'm leaving a few things out just for simplicity purposes. So since we want to have NOCl on the reactant side, and this reaction has NOCl on the product side, I'm going to flip this around. I'm going to reverse it, which means that's going to make my delta H positive. But also, I have a 2 coefficient in front of NaCl, which means I probably want to take this entire reaction and I want to multiply it by 2 when I reverse it. Okay, so that's going to leave you with 2NOCl yields 2NO plus Cl2, and then the delta H for that is going to be 77.2. Okay, so now this equation, we're done with it. Now, for the first one, what we should probably do is, since you have N2 as a reactant here, but it's a product here, we should probably reverse this reaction, and since this is a coefficient of 1/2, and this is a coefficient of 1, we should probably take this entire reaction and multiply it by 2 to get rid of that 1/2 coefficient. So I'm going to multiply it by 2 and I'm going to reverse the whole thing. So that means I'm going to get 2NO yields N2 plus O2, and my delta H is going to be negative 180.6. So this was positive as it was written, but since I reversed it and multiplied it by 2, now it's negative and it doubled. So to get the overall delta H of the reaction, you add these two values together, and you're going to get negative 103.4 kilojoules per mole of reaction. Okay? All right, then we go on to number 2. For number 2, the overall reaction that you want is this one, okay? But since the first 3 reactions that they gave us that we're supposed to manipulate to get this, since they have Cl2 as a reactant in the first reaction and Cl2 as a reactant in the overall, I'm going to leave that one alone. Then the second reaction has got C2H5Cl as a product. That's not a product here, but it has C2H4 as a reactant, and that's a reactant here. So we're going to take the second reaction, and we're going to leave that in the order that it is. Okay? And we're kind of just playing with it. Like, that's the only way that you can figure out what the real answer is just sort of by playing with it. Now, this third reaction has the desired product as a reactant. So I'm going to reverse it, and I'm going to put this on the reactant side, and the product side has these two substances, which means my delta H is now positive because it was negative to begin with. And then if you want to get the overall delta H, you would add these values together, and you should get negative 1.7. Okay? Okay. Then we have the third. And I'm not showing you how they cancel out. Do you want me to show you how they cancel out? Or we understand that? Okay. For the third, you're trying to get NO plus O yields NO2, and we want to know the delta H for the reaction, okay? They gave us 3 different reactions. Let's write them over here. Okay, so since we have NO2 in this reaction as a product, and it's a product here, I'm going to go ahead and leave this one alone. So we're done with that one. Now, since I have oxygen alone, and this is not O2, this is just O, and this reaction has O on the product side, I'm going to go ahead and take this reaction and I'm going to reverse it, but since it has a coefficient of 2, I'm going to go ahead and divide this by 2 and reverse it, because I've got to get rid of that coefficient of 2. So that's going to give me O yields 1/2 O2, which means the delta H that corresponds to this, it was positive 495, now it's negative 495 divided by 2, because I divided that reaction by 2. Okay, so now we're done with this one. Now, since we have O3, ozone, as a reactant here, I need to cancel it because it's nowhere in my final reaction, and there's ozone here in this reaction. I'm going to reverse it because I've got to find a way to cancel it out. And I only have one O3 here, so it'd probably be a good idea if I took this entire reaction and I divided it by 2 to get rid of that coefficient in front of O3. So that's going to end up giving you 3/2. So 1.5 O2 yields O3. And that's going to give you a delta H. Originally, that delta H was negative 427. Since I reversed that reaction, now it's a positive 427, and it's divided by 2, like this. So you would add these up, because these cancel. O2 plus a half O1 O2 plus a half O2 is 1.5, so these cancel. That leaves you with your overall reaction. That gives you negative 233 kilojoules per mole of reaction.